Hello friends, welcome to another session of Quant, and what we are talking here primarily in the quant topics that are relevant for your CAT and NMAT SNAP IIFT kind of exam. So currently we are discussing algebra. If you have seen the last few sessions, we talk about arithmetic progression, geometric progression, and their formulas, some part of their problems, which are very important. Actually, if you see for last few years CAT papers, and those are absolutely important. And every year we have seen questions coming out of AP, GP, or arithmetic progression, geometric progression section. So on that line, what we thought today is going to talk about what we are going to talk about today is one of the extension of AP and GP chapter, which is primarily talking about sequences. So when I say sequences, these are not completely a new chapter in your syllabus. If you scan through CAT syllabus, actually you may not see this. But however, what I feel is it will be very relevant to understand this, and this is an extended version of AP and GP. So you will possibly do the same thing that you were doing in APGP, but going depth inside on how to solve some of the sequence problems, or how to identify a problem of sequence easily, and what should be the approach to solve it. So APGP may have a different kind of problem, but this is focused on the version of APGP which specifically rely on sequences. Now the sequence, and we will show some of the techniques how to solve it, how to identify it, and then solve few of the problems to it. So without further ado, let's get started. So here, what we are going to talk about is primarily one thing, that is things that are given in sequence. You may have seen we have solved few problems like this earlier, and you will if you scan through some of the CAT papers, you will be able to see problems like this coming very frequently. So let's say there is a sequence which talks about, let's say, 3 plus 5 plus 7 plus, let's say, 9 plus 11, like this. So if you have a sequence like this, and someone asking you to find the sum of this, so you know this is a straight PP, and how you can identify? See, the difference between these two, 5 and 7 is also 2, 7 and 9 is also 2, 9 and 11 is also 2. So what we can say here, in the given problem itself, your common difference, or we say CT, is same in first stage itself. So first stage itself. So we can say this as first order. And I will show you what is second order, what is third order. But if you say in the first stage itself, your common difference is same. Or let's say in the same problem, not the same problem, but in the same way, if I give you, let's say, 3 plus 8 plus 15 plus 24 plus, let's say, 35, so on, and ask you to find the sum, what you will do? You can see the first level difference here is 5, here is 7, here is 9, here is 11. So the difference is at the first stage only. The common difference is not same. Somewhere it's 5, somewhere it's 7, then it's 9, then it's 11. If you do to the second stage, so 5 and 7 difference is 2, 7 and 9 difference is 2, 9 and 11 difference is 2. So I say common difference comes at second stage, right? So common difference here comes at the second stage. Once you do two-time calculation, or two-time difference calculation, if you do, you get the common difference, or the difference which are same across all the terms. In the previous problem, if you see, we got the same difference or the common difference by doing the subtraction at the first stage itself. Now you can see there may be another problem talks about 2 plus let's say 9 plus let's say 2 plus 9 uh, plus say 30. Okay, not 9, let's make it 10. 2 plus 10 plus 30 plus let's say 68 plus let's say 130, so on. If you see this series, obviously you won't be able to identify this is an AP, because at the first stage, if I see the gaps, these are 8, 20, 38, then this is what, 62. So these are the gaps. Obviously, no way we can see at the given shape and form, it's an AP. We can't say that. Now, if we do the second stage, what we'll get? You'll get 12, 18, then you get 24. So in the second stage also, you don't see the gaps are same. Now, if you go to the third stage, you will get 6, you will get 6. So I can see in the third stage, the common difference is appearing. So we can say the common difference coming in the third stage. So the first one, it's called the first order AP, where the common differences appeared on the first stage itself. First order, first degree AP. In the second one, it's called second order AP. So it becoming AP after you do the subtraction 2 times. In the third stage, it's called third order AP. Okay, because you got the common difference after doing subtraction 3 times, right? So that's how the differences are. Now, if you see, we can say in this case, in the first order AP, if you see what is my Tn, or the nth term is 2n plus 1. So every term, if you see, first term is 2 into 1 plus 1, that is 3. Second term is 2 into 2 plus 1, that is 5. Third term is 3 into 2 plus 1, that is 7. So you can see the commonality means 2n, which is 2n plus 1. A first order AP is denoted as 2n plus 1. So I'll just write it there. It's easy for you. So first order AP always denoted as Tn 2n plus 1. Okay. Right. Yeah. Tn equal to 2n plus 1. The second order AP, if you see, the Tn here is uh, n square. So if you see typically, it n square plus 2n. How we did that? 3 is what? 1 square plus 2 into 1. 8 is what? 2 square plus 2 into 2. What is 15? It's 3 square plus 2 into 3. What is 24? It's 4 square plus 2 into 4. What is 35? 5 square plus 2 into 5. So it's n square plus 2n format. This one, we can also write it as n cube plus n. If you see typically, what is n cube plus n? N cube plus n is basically 1 cube plus 1, that is 2. 2 cube plus 2, that is 10. 3 cube plus 3, that is 30. 4 cube plus 4, that is 68. Now, if you know this is easy to solve. If you can identify what is my Tn. Now, let's say I'll take the second example. What was the second example? Second, 3, 8, 15, 24, 35. Now, Sn, Sn 3 plus 8 plus 15 plus 24 plus 35. Now, from here until nth term, if this is the problem, from here, you can easily say that what is your Tn, or the nth term if you can identify the previous one, or that is n square plus 2n, if you can identify this, you can right away say that Tn is n square plus 2n, right? Tn is n square plus 2n. Now, if they say n is, okay, you have to find the sum till 20th term. If this is find the sum till 20th term instead of nth term. Now, you know Tn is n square plus 2n because this is the generic formula of all the terms. Now, we can say S20 is nothing but summation of n equal to 1 to 20 n square plus 2n. You can do this. So 20 terms, so n equal to 1 to 20 n square plus 2n. Now, if I further break it, it will be n equal to 1 to 20 n square plus n equal to 1 to 20 2n, right? I'm just breaking this. So this is nothing but 1 square plus 2 square plus 3 square plus 20 square. So, and this one is 2 common, 1 plus 2 plus 3 multiplied by 20. So this is the sum we just need to calculate. So in the first one, you know, n square, 1 square, 2 square, 3 square, n square formula is n, which is 20 here, n into n plus 1, which is 21, into 2n plus 1, which is 41, 2 into 20 plus 1, that is 41, n into n plus 1 into 2n plus 1 divided by 6, and this one n into n plus 1 by 2. So you just need to calculate this and you'll get the sum, right? But the whole premise is depending on the fact that you can identify the generic term of Tn, what is given, because this much will only be given to you, and from here can you identify n square, Tn is n square plus 2n, because tomorrow I give you some other term, other generic form, which is also a second degree, but you can't always tell that this is going to be n square plus 2n. How? Let's say I just think this, okay? Let's say there is another sum which typically talks about 2 plus 6, okay? 2 plus 6 plus 12 plus 20 plus 30 and so on. Now, what is the first? See where you get the common difference, which order it is. This is 4, this is 6, 12, 28, 20, 30, 10. So this is not an AP in this case as of now. If I do again 2, 2, 2. So it is a second order AP. Now second order AP does not mean it is n square plus 2n always. N square plus 2n will make 3 plus 8 plus 15 plus 24, but this is a different set. So not all second order AP can be written as n square plus 2n. So this is a generic term for that given sequence only. So here it is actually n square plus n. But since I have created it, I will be able to identify easily. But for in a given exam setup, if you can identify what the problem setter has in mind when they written this, or you can quickly identify what is the generic term of Tn which can explain all the terms with the form of the generic term, then bingo, you are on the right track, and go ahead and solve it like this. If you can do it, that's the fastest way. And I'm not discouraging you to do it. Actually, I'm encouraging, if you can identify by seeing the terms only, what is the generic term going to be. First, you have to do identify which order AP it is, first order, second order, third order. Now, once you identify first order, second order, third order, it is kind of easy for you to identify what is the generic term, right? The generic term in the previous case is n square plus 2n. In this case, it's n square plus n. So if you can identify the generic term, go ahead and solve the problem right away. There is no doubt in that. But if you can't identify the generic term right away, how you are going to solve? Now, If it is a first order AP, the generic term of Tn is normally read as the common sequence is an plus b. If you can't read the generic term right away, write the standard form of a generic term, which is an plus b. If it is a second order AP, the generic term will be an square plus bn plus c. Since it's a second order, the highest degree here is 2. So if you go back here also you will see the first order AP, the generic term is 2n plus 1, where the highest power is 1. Second order AP, the highest power is n square, or highest power is 2. Third order AP, if you see, the highest power is 3. Okay, so I'm just generalizing this in a standard form. So if it is a third order AP, your Tn an cube plus bn square plus cn plus d. Okay, so this is the, I will say this is the standard form. So this is the standard form of writing a sequence once you identify which order sequence it is. If it is a AP sequence of second order, then you can write this as a standard form. If you identify a AP sequence of third order, becoming the AP at third order, then it is this. You have to write this. Okay. Now, if you understand this, now let's try to solve the same previous problem, 2, 6, 12, 20, 30, how you can solve this. So let's say you got the same problem, 2 SN 15, not 15, 2, 6, 12, 20, 30. So you got the same problem. Okay. Now you don't know how to find the generic term of it, how to find Tn. How to find Tn just by saying it. You are not able to see it is n square plus n as the generic term that can explain all the other terms. So you are not able to identify that. Then how will you do? So the first stage for you is to find out which order AP it is. So it is 4, 6, 8, 10. So I know in the first order it is not making an AP because the common difference is not same. In the second order, it is making an AP. So it's a second order AP. Okay. Now, if you identify the second order AP, what is the standard form? The standard form tells me from the previous stage, the standard form tells me an square plus bn plus c is the standard form. So I'll write an square plus bn plus c is my standard form. Okay. Now let me see if I can find out A, B, C equal to how much. This is my core ask, and we have to do that. Okay. So how I can say what is my T1? My first term is 2, and 2 is equal to n equal to 1. If n equal to 1, then this is A plus B plus C equal to 1, 2. What is my T2? My T2 is 6, or 6 is equal to the second term. So, which is 2 square. N is equal to 2. N is equal to 2 means 2 square. So 4A plus 2B plus C. What is T3? My T3 is 12. So 3 square. So 9A plus 3B plus C. So I have 3 unknown. I have 3 equations. So these are my equation 1, equation 2, and equation 3. Okay. Now you can solve this 3 equation and get the value of A, B, and C. Okay. How I can do that? So let's say I do 2 minus 1. So 2 minus 1, I get 4A plus 2B plus C minus A plus B plus C is equal to 4. Okay. So this is becoming 3A plus B equal to 4. So 3A plus B equal to 4. So we got one equation. Let's say I do 3 minus 2. So what I'll get? 9A plus 3B plus C minus 4A plus 2B plus C is equal to 6. Okay. Again, C will get cancelled. So what I'll get, I'll just write it here. 9A minus 4A is basically 5A, and 3B minus B is B. So 5A plus B is equal to 6. Okay. So we got two equations. This is one equation, 3A plus B equal to 4. We got one equation, 5A plus B equal to 6. So I'll just write it. 3A plus B equal to 4, 5A plus B equal to 6. So again, so if I just write 5A plus B minus 3A plus B, that is 6 minus 4. So 2A is equal to 2, or A is equal to 1 for me. If I put A equal to 1 in this case, I'll get 3 into 1 plus B equal to 4, or B also equal to 1. So I get A equal to 1, B equal to 1. Okay. I get A equal to 1 and B equal to 1. Now, what is my first case? A plus B plus C equal to 2. This one, I'll just put A plus B plus C equal to 2. So I'll put 1 plus 1 plus C equal to 2, or C equal to 0. So I get A equal to 1, B equal to 1, C equal to 0. So this is my final values of A, B, C. Now, if I go back here, what was my generic term? N square plus Bn plus C. So my Tn was An square plus Bn plus C. Now A is 1, B is 1, so my C is 0, so my Tn become N square plus N. So this is one way. No, I know it's a little longish way to calculate, but this is the way to solve it if you cannot identify the generic term right away. You have to write the standard form of it, put the values, get the equation, solve it, and get the generic form. So once you get the generic form, the idea is to follow the same approach we did here. Where we did Tn equal to N square plus N, and then the same way. So the idea here is, if you can identify the generic term of Tn, best go ahead and solve the problem. If you can't identify the generic term of Tn, you have to write the standard form, and by standard form I mean all these three standard form: An plus BB, An square plus Bn plus C, An cube plus Bn square plus Cn plus D for the third order. So you have to write those standard forms, and once you write the standard forms, you just have to first you identify which order AP it is, then identify the right standard form, and then put out the values of N and based on the terms that are given to you, and create those equations, solve it, and get the generic term. So this is the way you can solve it. Okay. So this is a very important understanding on how to solve sequences when you are not able to identify the Tn right away, or how to identify Tn right away. Is basically you need to understand first which order AP it is, and then you can do it. So these are one thing that we want to cover. Like AP, there are also GP problems which you can tackle through this type of sequences. So we'll now look into that. Now let's say there is a sum where you need to find out 1, 3, 7, 15, 31, and so on. Okay. Now, you can see the gap here is 2, 4, 8, 16. So I can say my common ratio is same in first order itself. So it is GP of first order, because I got the common ratios same in the first order. If it is not, the common ratios are not same, I have to do the subtraction one more time, then it would have been GP of second order, right? So here the standard form is Tn a r to the power n minus 1 plus bn plus c, right? So this is the standard form of a GP. Okay, a r to the power n minus 1 plus n plus c. Okay, so what we can know from here, what is my T1? My T1 is 1. So it is a r to the power 1 minus 1 plus b into 1 plus c, or we can say a plus b plus c. R to the power 0 is 1. Similarly, what is my T2? My T2 is 3. This is a r to the power n is 2 here. So 2 minus 1 plus b into 2 plus c, or we can say ar plus 2b plus c, right? So that way you can calculate this. So there are four variables. So you have to write four equations and solve it. So this is one way which we can say that sequence may not be always coming from AP, but sequence may coming from GP also. Primarily, most of the cases what we have seen, the sequences are in AP, but there are cases where sequences can be in GP, and this is your standard form of writing the sequence. Okay. If in say first order AP, can write it like this. Okay. So with this, let's try some of the problems. Let's see some of the different type of problem that can come in a sequence. Let's see. Let's say there is a problem. You have to find out Sn. Okay. You have to find out Sn of, to find now Sn of 1 plus let's say 4 by 7 plus 9 by 7 square plus 16 by 7 cube plus 25 by 7 to the power 4 till infinite. Okay. Now, if you got how we are going to solve it. So if you see here, if you try to see here, your numerator are increasing in the series of squares, 1 square, 2 square, 3 square, 4 square, and the denominator is increasing at the level of power of 7. So can I write my Tn is equal to n square by 7 to the power n minus 1, because my first term is 7 to the power 0, second term 7 to the power 1, third term 7 square, fourth term 7 cube. So my Tn is n square by 7 to the power n minus 1. So this is my Tn. Now, listen, this has to go till infinite term. So with the Tn formula, you may not be able to justify it completely because it's a sum of infinite term. Okay, so the sum of infinite term, only one came into picture. When you back of your mind, you should know this is going to some form of GP, because GP has the only formula for calculate infinite term. So just to revisit, a by 1 minus r. If there is a GP series of s of infinite term, a plus ar square, and so on till infinite terms. So the sum of that is this. So a by 1 minus r. So only GP has the infinite sum, a formula. Now, you know, this is basically then going to be a GP. Now, how to do it? So that's where you need to do some changes, and let's say s of infinite. So this is infinite. S is 1 plus 4 by 7, 9 by 7 square, 16 by 7 cube, 25 by 7 to the power 4 till infinite. Now I can write the same infinite term. Okay. Now I can write the same infinite term, just multiplying it by 1 by 7 and start writing, leaving the first one. Since it's infinite term, if I leave the first one, it will not change. So my first term will become 1 by 7. So instead of writing 1 by 7 right below 1, I write right below 4 by 7. That's I shifted this the right one in it. Some of this problem we solved in the previous session. Just a recap and see how we can solve some of this. So these are not necessarily what we have talked till now. We have solved some of the type of sequences, how to find out the generic term through standard form, through identification. That's what we did earlier. Till now in the session, what we're trying to do is trying to solve few typical type of sequence problem, which may fall in the bracket which we talked till now, which may not fall in the bracket till now. So these are the very valid sequence problems. I thought of revisiting it once again. And a quick recap of what we did in AP, GP advanced level problems. So this is one of the CAT years of CAT problem, and actually we can try to solve this. So then 1 by 7, the next term will become 4 by 7 square. The third term will become 9 by 7 cube, and till infinite. Okay. Now, if I subtract my s minus 1 by 7s is equal to 1. First term 3 by 7, second term 5 by 7 square, fourth term your 7 by 7 cube term. This will be 16, so 9 by 7 to the power 4, because here will be 16 by 7 to the power 4. Okay, so 9 by 7 to the power 4. So still not a complete AP or a complete GP. On the top, we can see it's forming an AP. Below, it's forming a GP. So we have to come to some part of it. Okay. Now I will write it in the next page completely. So what we did, s minus s by 7 is equal to 1 plus 3 by 7 plus 5 by 7 square plus 9 by 7 cube till infinite, right? Okay. Now this is your what? This is your 6s by 7. 6s by 7 is equal to this 1 plus 3 by 7 plus 5 by 7 square plus 9 by 7 cube and so on till infinite. Okay. Now this is your 6s by 7. What you have to do now? So the same term, if you keep shifting one, so what is your Tn now become? Your Tn become 2n plus 1, because the above part is an AP and the below part is in GP. So this is 7 to the power n minus 1. So it is basically still the same way how it was earlier. It is still basically the same way how it was earlier. Now we should, so it is still not a GP. So again, we do the left hand side divide by 7. So what we'll do, 6x by 7 into 1 by 7. So again, we are doing the same thing like we did the first level, first order. It is not still a GP completely. So we do 1 become 1 by 7 and writing one shift after. So 3 by 7 square, 5 by 7 cube, and so on till infinity. Now this, what it become, 6s by 7 minus 6s by 40, sorry, 6s by 49 is equal to 1 plus, sorry, this is 6s by 7 into 1 by 7. 1 plus 2 by 7. This. Okay. 1 plus 2 by 7. Since I started writing after the first term, this is 2 by 7 square. This is 2, 3. So this is should be 7. Yeah, 7 was cube, so my bad. This is 7. So this is 2 by 7 cube, and so on till infinite. Okay. Now, because 3 by 7 minus 1 by 7 is 2 by 7, 5 by 7 square minus 3 by 7 square is 2 by 7 square, 7 by 7 cube minus 5 by 7 cube is 2 by 7 cube. Now, if you see typically, this part becoming 1 plus 2 common, so 1 by 7 plus 1 by 7 square plus 1 by 7 cube till infinite. So now this is becoming AP. So you can apply the GP formula here in this case and find out the problem. So let's say what is becoming. So 6s by 7 minus 6s by 49 is 1 plus 2 into 1 by 7, 1 by 7 square, 1 by 7 cube till infinite. This is what you have. So 1 plus, you take 2 common, a by 1 minus r we said. So a is 1 by 7, the first term, 1 minus r. R is again 1 by 7. So 1 by 7. And so the left hand side becomes, this is 49, 7, 6, so 42s minus 6s. So that is 36 s by 49 is equal to 1 plus 2 into 1 by 7 into 7 by 6. And 7 get cancelled. So 36s by 49 is equal to 1 plus 2 by 6 or 1 by 3. And then from here you can calculate s. So that's how you can do it. So like I said, so there are no fixed ways how you can solve it, but we just try to solve one problem and see how we can solve it. So this is one type of problem I want to give you a glimpse on how to solve it. But yeah, now since we have solved most of these problems, I hope you understood APGP with the series of sequence that we have solved. So how to find out the generic term, how to find, if you don't find the TN right away, how to use the standard form by knowing what order AP or GP it is, and then get the standard form and from there get the solution. Or if it is a mix of AP, GP, how to go ahead and start writing the infinite series of it and identify, okay, if there is an infinite series, that means it has to convert it into a GP. Now, how I can convert into a GP, at which order? And then from there, how we can calculate. So I think these are the few things I just want to cover in terms of the sequence, and that concludes our topic of discussion around APGP. If you like it, please feel free to like, share, subscribe the video for the algorithm and for my motivation to create such free videos for you, which will help you unblock your thinking or help you completely ramp up on topics which are very, very relevant for your MBA entrance exams in terms of quant. Okay, see you next time. Have a good day. Thank you. Bye.